In November 2025, scientists made a groundbreaking discovery while observing the mysterious comet 3I Atlas aboard the European Space Agency's JUICE spacecraft after it passed by the Sun. What they found was shocking: a meteoroid with two tails, one dust tail and one plasma tail. This discovery made 3I Atlas a fascinating subject of study for scientists. The more they studied, the more questions arose about the mysteries surrounding 3I Atlas. What do its unique features reveal about the Milky Way, and possibly life on Earth? Stay tuned to discover shocking truths waiting to be revealed. The discovery of 3I Atlas has sent shockwaves through the scientific community. It's not just any comet. This is an interstellar comet, the third ever discovered, and it's unlike anything we've encountered in our own solar system. What sets 3I Atlas apart is its origin. While comets typically form within their star systems, 3I Atlas comes from another star system entirely, having traveled across interstellar space for billions of years. In July 2025, the comet was spotted as it entered our cosmic neighborhood, sparking widespread interest. Unlike familiar comets, 3I Atlas doesn't follow typical cometary patterns. As it passed closest to the Sun in October 2025, scientists expected it to fade, but instead, the comet brightened. This reaction raised eyebrows, as comets usually cool down after perihelion, releasing gases and dust. Instead of chaotic outgassing, 3I Atlas exhibited a smooth coma, suggesting it behaves differently from other comets. This indicates that 3I Atlas reacts to solar heat in a unique way, possibly because it originated in a colder environment, like a red dwarf star. The chemical composition of 3I Atlas is another mystery. Scientists detected methanol and hydrogen cyanide in the comet's tail, chemicals that are rare in our solar system. These substances challenge our understanding of how life and planets might form in other star systems, pushing the boundaries of organic chemistry in space. This discovery raises important questions about how these building blocks could play a role in the formation of life beyond Earth. What makes 3I Atlas even more significant is its age. It's potentially older than our Sun, acting as a time capsule from an era long before our solar system formed. Its existence could hold the key to understanding the origins of our galaxy and the processes that led to the birth of star systems. As we continue to gather data, scientists are piecing together how 3I Atlas fits into the broader picture of the universe. This comet challenges what we know about comets and may ultimately reshape our understanding of the cosmos. Now let's dive into the observations made by JUICE, which have given us a clearer picture of this extraordinary interstellar visitor and its behavior. In November 2025, the European Space Agency's JUICE, Jupiter Icy Moons Explorer, spacecraft made significant observations of the interstellar comet 3I Atlas, shedding new light on the mysterious behavior of this celestial object. Although not specifically designed for cometary studies, JUICE was able to provide valuable data as 3I Atlas re-entered the solar system and passed near the Sun. JUICE observed 3I Atlas shortly after it reappeared in our cosmic neighborhood. The data collected revealed unexpected findings, notably the comet's ongoing activity. Unlike typical comets that fade after passing the Sun, 3I Atlas maintained a bright coma and continued to release material, demonstrating more activity than anticipated. One of the key discoveries made by JUICE was the confirmation that 3I Atlas does not only have a plasma tail, as many comets do, but also a clearly defined dust tail. This dual-tail feature is rare among comets and adds to the uniqueness of 3I Atlas. While most comets have a primary tail composed of gas and ionized particles, plasma, 3I Atlas's dual tails suggest complex interactions with the solar wind and the comet's volatile material. These observations are crucial because they offer new insights into how interstellar objects behave when exposed to the sun's radiation. The data from JUICE allows scientists to study the behavior of material from another star system as it interacts with the solar wind and heats up. This information helps to advance our understanding of the processes at work within the interstellar medium. JUICE also captured data on the brightness of the comet's coma, revealing that 3I Atlas is emitting more gas than previously expected. One of the most intriguing aspects of the comet is its changing color as it approaches the sun. The color shift, coupled with the intensity of the coma, suggests the presence of chemical compounds not commonly found in other comets from our solar system, making it a subject of intense study. With the data collected from JUICE, scientists are now working to model the comet's behavior in the coming phases of its journey. The continued activity of 3I Atlas as it moves farther from the sun is a key area of study. The presence of both a dust and a plasma tail indicates complex processes taking place within the comet, which is unlike most of the comets observed in our solar system. Moreover, JUICE's observations of the comet's trajectory are providing important clues about the movement and frequency of interstellar objects in the solar system. These findings suggest that objects like 3I Atlas may not be as rare as previously thought, and their interactions with the solar system could offer insights into the dynamics of our cosmic neighborhood. JUICE's discoveries have significantly advanced our understanding of 3I Atlas, offering a rare opportunity to study an interstellar object in detail. The spacecraft's data is providing valuable information not only about this specific comet, but also about the behavior of interstellar objects as they pass through our solar system. As the data continues to be analyzed, these findings will undoubtedly contribute to a deeper understanding of the processes at work in the broader cosmos. The unique characteristics of 3I Atlas are poised to remain a central topic in scientific research for years to come. The more scientists study 3I Atlas, the more they uncover its unique chemical composition. This interstellar comet isn't like the comets we've studied within our own solar system. 3I Atlas has revealed that its chemical signature is vastly different from what we've come to expect from typical solar system comets. For example, scientists have detected high levels of methanol and hydrogen cyanide in the comet's tail, chemicals that are generally found in comets, but at far higher concentrations than we're used to seeing. This discovery raises important questions. Why does 3I Atlas have these chemicals in such unusual amounts? What does this tell us about the environment in which it was formed? These findings provide key insights into the origins of 3I Atlas. It's believed that this comet originated from a different star system, possibly one that formed around a red dwarf star. These stars are cooler than our Sun, which could explain the unique chemistry observed in the comet. Unlike comets from our own solar system, which have been exposed to the Sun for billions of years, 3I Atlas has been traveling through the vast, cold stretches of interstellar space. This long exposure to cosmic radiation could have dramatically altered its chemical makeup, changing how the molecules interact and how they are released from the comet. This isn't just a simple case of finding a few unusual chemicals. The irradiation that 3I Atlas has undergone during its long journey through space is believed to have transformed its surface. Scientists estimate that the outer layer of the comet is about 50 to 65 feet, 15 to 20 meters deep, and it has been chemically modified by cosmic rays for billions of years. This crust is not pristine material like comets we typically observe. Instead, it's been altered by years of exposure to galactic cosmic rays, which means the chemical compounds on 3I Atlas have been slowly transformed over time. As 3I Atlas approached the Sun, The intense heat from our star caused this outer crust to vaporize, releasing gases that are revealing even more secrets about the comet's origin. This is a unique opportunity for scientists because 3I Atlas may contain untouched primordial material, the kind of material that has been preserved in the cold darkness of interstellar space for billions of years. However, as this crust evaporates, scientists are hoping to catch a glimpse of the raw materials that were once hidden beneath the surface, which could give us valuable clues about how matter is distributed in the early stages of a star system's formation. The chemical composition of 3I Atlas is providing new perspectives on how comets form, behave, and interact with their environment. Unlike comets from the solar system, this interstellar visitor is teaching us that cosmic material can undergo drastic changes as it travels through space. This could have important implications for how we understand the chemistry of other planetary systems, both near and far. The presence of methanol and hydrogen cyanide on 3I Atlas, for instance, is giving scientists a fresh look at prebiotic chemistry, the building blocks that could have contributed to the origins of life. As more data from JUICE and other telescopes arrive, scientists will continue to study 3I Atlas's chemical composition, and what they find may change the way we think about the formation of planets and life across the universe. Could 3I Atlas hold the key to understanding how life could develop in other star systems? The possibilities are vast, and the more we learn about this comet, the more we realize how much we still have to discover. As we wait for the complete data set to be transmitted, the journey of 3I Atlas continues to unfold, revealing new and surprising details about this extraordinary interstellar visitor. Now that we have an understanding of the comet's chemical composition, let's explore how 3I Atlas's dual tails provide more insights into its behavior and what that might mean for future cometary studies. One of the most striking features of 3I Atlas is its dual tail structure, which sets it apart from most comets observed within our solar system. Typically, a comet has only one tail, which forms when the sun's heat causes the comet's ice to vaporize, releasing gases and dust particles. These particles are pushed away from the comet's nucleus by the solar wind, forming a plasma tail made up of ionized gases. However, 3I Atlas exhibits two distinct tails, something rarely seen in other comets. The first tail, which is the plasma tail, behaves just as we expect from comets. It stretches away from the comet in the direction of the solar wind, made up of ionized gas particles that are shaped by the sun's radiation. This tail is what we typically see in most comets, as it forms due to the interaction of solar radiation with the gases released from the comet's surface. However, the second tail of 3I Atlas is far more unusual. This is the dust tail, which is made up of solid particles released from the comet as its icy surface sublimates. Unlike the plasma tail, the dust tail doesn't always follow the direction of the solar wind. Instead, it is influenced by the comet's orbital path, meaning the particles are released and driven in the opposite direction of the comet's motion through space. This feature raises an intriguing question. Why does 3I Atlas show such an unusual tail structure compared to other comets? The dual tail structure is important for several reasons. Firstly, it shows that interstellar comets like 3I Atlas may behave differently than the comets from our solar system. While the plasma tail is common and predictable, the dust tail's direction suggests there could be other forces at play, perhaps something unique to the formation and journey of 3I Atlas through interstellar space. These differences could be the key to understanding how interstellar objects like 3I Atlas interact with their environment and whether their behavior can help us make predictions about other objects in the future. Moreover, the observation of these two tails raises new questions about how solar systems evolve and how material is transferred between different star systems. Could the presence of this dust tail mean that interstellar material behaves differently from what we've observed in the past? Does it hint at a new way we should approach the study of cometary bodies from other star systems? As we continue to observe 3I Atlas, scientists are eager to study these two tails in greater detail. This unique feature has the potential to offer new insights into the behavior of interstellar comets, which could have broad implications for how we understand the formation of planetary systems and the potential for life in other parts of the universe. The fascinating structure of 3I Atlas's tails is just one of many questions scientists are hoping to answer. With more data arriving soon, the true significance of these tails will likely reveal even more about the comet's origins and the mysteries of space. Now let's take a deeper dive into the age of 3I Atlas and how its ancient nature could help us understand the history of our galaxy and the development of life across the stars. One of the most fascinating aspects of 3I Atlas is its age. Unlike the comets we typically observe in our solar system, 3I Atlas is believed to be several billion years old, potentially even older than our Sun. This makes it a cosmic time capsule, carrying with it material from a distant star system that has traveled through space for billions of years. The comet has been exposed to the cold depths of interstellar space for most of its existence, allowing it to preserve its original composition and offering us a rare glimpse into a time long before our Sun was born. The age of 3I Atlas isn't just an interesting fact. It provides scientists with a unique opportunity to learn about the formation and evolution of stars and galaxies. By studying the comet's chemical composition, researchers hope to uncover clues about the processes that led to the birth of star systems and the formation of planets in other parts of the galaxy. The chemical makeup of 3I Atlas could reveal information about the early stages of galactic evolution, including how material was distributed in the formation of planetary systems like our own. What's even more intriguing is the possibility that 3I Atlas holds untouched material beneath its surface. Scientists believe that the cosmic rays it's been exposed to during its long journey have altered its surface. This irradiation has created a thick, hardened crust that is estimated to be about 50 to 65 feet deep. Unlike comets in our solar system, 3I Atlas has never been exposed to the Sun for billions of years, and this crust has likely preserved its original chemistry, making it a unique specimen for study. As the comet approached the Sun, its intense heat began to cause the outer layer to evaporate. This could reveal pristine ice and other compounds that have been locked away for billions of years. This makes 3I Atlas not only an ancient relic, but also a potential source of primordial material, offering clues about the conditions that existed in the early stages of galactic formation. It's a rare opportunity to study a comet that has spent most of its life in the cold depths of space, untouched by the Sun until now. The chemical composition of 3I Atlas also raises important questions about the potential for life elsewhere in the galaxy. Some of the organic compounds found in the comet's tail, such as methanol and hydrogen cyanide, are key ingredients in prebiotic chemistry, the building blocks of life. This could mean that the conditions for life might be more common than we previously thought, and that similar chemical processes could have occurred in other parts of the universe. In this sense, 3I Atlas could offer valuable insights into how life might develop in other star systems, even if they are far from our own. 3I Atlas is challenging our understanding of the life cycle of interstellar objects. It has survived billions of years in the cold void of space, and now, as it moves through our solar system, it is offering us an unprecedented chance to study an object that has been shaped by cosmic forces for eons. The study of 3I Atlas can reveal how interstellar material behaves as it moves between star systems and how it affects the formation of new stars and planets. As we continue to study 3I Atlas, we are learning more about its role in the larger cosmic picture. This ancient comet holds the key to understanding not just the origins of our solar system, but also the history of the galaxy itself. With more data on the way, we are poised to uncover even more secrets about the formation of the universe and the potential for life elsewhere. As 3I Atlas continues its journey through our solar system, scientists are still grappling with the many unanswered questions it raises. Unlike typical comets, which we observe as they approach the Sun and eventually fade away, 3I Atlas has been far more enigmatic. From its unique chemical composition to its unusual tail structure, this comet is forcing scientists to reconsider their understanding of how comets and even entire solar systems form and evolve. What makes 3I Atlas so significant isn't just its journey through our solar system, but how it might change the way we view the broader universe. One of the biggest questions that still looms is, how does 3I Atlas compare to comets from other star systems? We've already seen that 3I Atlas behaves differently from comets in our own solar system. Its dual-tail structure, its chemical signature, and the smooth coma all point to a comet that has experienced conditions in its star system that are drastically different from ours. This raises an important question. What does this tell us about the other star systems in our galaxy? Could other interstellar comets also have similar features, shaped by forces and environments we've never encountered before? The answer to this question is crucial because it could change the way we think about the formation of other galaxies and the star systems they contain. If 3I Atlas is an anomaly in terms of its behavior, we might expect other interstellar objects to show the same complex structures. This could tell us something about the chemical diversity of objects across the galaxy and the potential for different kinds of planetary systems. For instance, if other interstellar objects behave like 3I Atlas, it would provide a clue about the diversity of planetary environments in the galaxy. Another mystery scientists are keen to solve is the source of 3I Atlas's unique chemical composition. It's known that 3I Atlas is rich in methanol and hydrogen cyanide, compounds that are also important in the chemistry of life. This comet could hold clues about the chemical building blocks of life and how they might have formed in other star systems. If life-supporting chemicals can exist on comets from other star systems, what does that mean for the potential for life elsewhere in the universe? Could this comet be the first of many, carrying prebiotic material that might one day lead to the emergence of life in other corners of the galaxy? The more scientists study 3I Atlas, the more they realize how much they still don't know about it. Each new discovery seems to raise more questions than answers, but that's what makes this mission so exciting. This comet isn't just a strange visitor, it's a window into understanding the universe in ways we never thought possible. As more data comes in, scientists hope to piece together the true story of 3I Atlas and what it can tell us about the galaxy. And who knows, perhaps 3I Atlas will open the door to interstellar exploration and the discovery of other objects that could change everything we thought we knew about space. The data we receive in the coming months could reshape our understanding of the solar system and the universe itself. Will 3I Atlas answer the questions that have been lingering for centuries? As we dig deeper, we may uncover new mysteries that push the boundaries of our knowledge and help us explore the hidden corners of space. The observations of 3I Atlas have opened a new chapter in interstellar exploration. The more we learn about this comet, the more we realize how little we know about the objects that come from beyond our solar system. 3I Atlas is just the third confirmed interstellar object, and yet its unique properties are already forcing scientists to rethink everything they know about the formation of comets, star systems, and even life itself. What does the future hold for interstellar exploration, and how will 3I Atlas shape our understanding of the universe? For one, the future of space missions is about to change dramatically. With new telescopes and spacecraft like JUICE, James Webb, and Hubble, we're poised to explore more interstellar objects in the coming years. Each of these missions will bring us closer to understanding not just comets, but the materials that travel between stars, carrying with them information about the origins of life and the evolution of galaxies. As new technology improves, the ability to observe interstellar objects will only get better, offering new insights into the physical and chemical makeup of these objects and how they interact with their environments. One of the next steps in interstellar exploration will be the study of other interstellar objects that may be out there waiting to be discovered. The scientific community has already predicted that we will encounter more interstellar visitors in the future. In fact, some experts suggest that thousands of interstellar objects could be passing through our solar system at any given time. But because they are often too faint to detect, only a few are spotted during their brief journeys through our neighborhood. The good news is that as observatory technology advances, scientists will be able to detect these objects earlier, track their movements, and study their behavior in much more detail. This could lead to even more groundbreaking discoveries in the coming years, as we learn more about the interstellar medium and how it impacts the formation of stars and planets. 3I Atlas is just the beginning. As we learn more about its composition, behavior, and history, we're gaining valuable insights that will guide future missions and discoveries. One of the most exciting possibilities is that interstellar exploration will give us the tools to study alien worlds, possibly uncovering traces of life beyond our own planet. The discoveries made through missions like JUICE and James Webb will not only expand our understanding of comets, but also help us search for life in other parts of the universe. As we look ahead, we can only imagine what will come next in the world of interstellar exploration. The mysteries of the universe are vast, and 3I Atlas has already provided us with a glimpse into what lies beyond the stars. The journey of 3I Atlas isn't just a scientific mission, it's the first chapter in an unfolding story about our place in the universe and the potential for life on other planets. The more we learn, the more we realize how much there is still to discover. As we've seen, 3I Atlas is far from an ordinary comet. Its unique features and unexpected behavior raise fascinating questions about the origins of our galaxy and the potential for life beyond Earth. The discoveries made so far are just the beginning, and as more data arrives, we may unlock even greater secrets about the universe. Could 3I Atlas be a key to understanding how life spreads across galaxies? Or does it hold clues to a much larger cosmic mystery? Share your thoughts with us in the comments. What do you think this interstellar comet could reveal about the future of space exploration?